Welcome to the FCICA product webinar series. Thank you for joining us. We are pleased to have David deBear with us today presenting Flooring Sound Control for Tile, Stone, and Hardwood. David deBear is the Director of Architectural and Commercial Sales for NAC Products and is a certified tile consultant. David brings over 30 years of combined education and experience to the design and construction communities on the proper specification, surface preparation, and installation of ceramic, porcelain, natural stone tile, and masonry. With his background in the construction industry and comprehensive knowledge of building materials and methods, David serves architects, GCs, and specifiers, both as an educator and as an industry resource. In addition to developing over 24 AIA CES Registered Programs, he has received the AIA CES Award for Excellence. David represents NAC Products on the ANSI Accredited Standards Committee, ISO Technical Advisory Group, and the Tile Council of North America. Welcome, David. We're excited to have you. I'm going to turn the controls over to you.
Thank you for having me and to share a little knowledge with you guys. This week's been a little bit difficult for everybody with the fires on the West Coast and Hurricane Laura getting ready to pounce down there in the Gulf. I hope everybody is safe and has made accommodations for friends and family, what have you. And also, thanks for taking time, and I hope everybody's doing really well considering the pandemic issues that we're all going through right now, and taking time out here to further our education and move forward with our business at the same time. So I hope everybody is well. Today's topic is sound control underlayments, sound attenuation membranes and systems and what have you. I'm going to apologize up front. It's kind of a dry technical program. However, the way I see it, even the pros have to go back to training camp every year to hone their skills. So I'm ever hopeful that we'll be able to translate some of the technobabble related to sound engineering into things that we can all use. And certainly at the end of this entire presentation, if you take nothing away but my phone number, that's a good thing too. So our objectives today, we're going to give you some pretty skinny down but accurate and detailed information on how to design a sound rated assembly for tile, stone, and other hard surfaces such as hardwood, LVT, and different types of hard surface flooring. When we're all finished, you'll be able to either specify or read a spec and digest the information that is in there so we can create an effective system that will comply with all the building codes and all the architectural requirements. And if you're dealing with condominium associations and the like, their requirements, as we'll dive into here shortly, oftentimes are a little bit different as well. Sometimes they try to supersede the building codes and standards to sell their product as a luxury product, which is a good thing. So what is a membrane? First of all, on the left, you'll see that there's a sheet membrane with an adhesive on the back. This particular one we're looking at there has a little ribbon on the face. You overlap it and it creates a waterproofing membrane as well as sound attenuation and anti-fracture. On the right-hand side, you'll see the paint roller going on there. There's liquid applied materials as well. Liquid applied materials do not necessarily have value when it comes to sound attenuation. But if you need waterproofing or a thin load-bearing anti-fracture membrane for tile or stone, or even a lighter duty moisture vapor barrier, the liquid applied materials are the way to go for that. You can use the combinations in certain instances, but there's a lot of different opportunities out there for you, different types of materials. Those are the two basics right there. So why should we be concerned with floor ceiling noise issues? Okay, when we talk about condominiums and love thy neighbor, the number one complaint here is noise. You as a tenant or homeowner in a condo you don't want to hear the neighbors, and don't take it personal, but I don't think they want to hear you either. When we have a system that's deficient or doesn't meet the codes or is not put into building at all, oftentimes it leads to flaring tempers, if you will, litigation, building permits can come into play, certainly if you're not meeting code requirements and what have you. So these are the things that we should be concerned about when we're looking at this, whether for an individual retail client or perhaps for a commercial client going into a larger scale production thing. You want to take a look at all of these things way up front and make any corrections through changing the specs or RFIs or what have you before you get in there and end up in the courtroom, or at the very least, an argument with somebody. So how do we dive into this thing? Industry standards are a good technical way to start. This is where the architect and certainly the guys employing the building codes and enforcing building codes, this is where they're going to look first. These are practices that define the installation of hard surface, not only test methods and properties, but also the installation of those things. And we're going to dive into all of those aspects. And these are all recognized by the industry professionals. The ANSI standards, certainly ASTM, which dictates test protocol to find out the value of a system or a product. In the ceramic world, it's the Tile Council of North America, which has in its handbook for tile installation several methods in there for sound isolation and crack isolation, as it may be. The National Tile Contractors Association and the TCNA, the union group, all those guys have people from the various areas of the industry that sit on the ANSI committees. I'm one of them, as noted in the intro. And as such, several years ago, an ANSI standard was created specifically for sound underlayments in a ceramic tile or stone installation. And some of this will translate, and we've seen it translate into hardwood and LVT, certainly when it comes to sound attenuation. I was surfing around on a couple of websites for some prominent manufacturers, and there's a lot of tremendous information out there that'll help you understand the products, the combinations of products and whatnot, and how these products are measured, whether it be ANSI, ASTM, or another form. So let's take a look at this. There's two different ways to measure sound. Okay, IIC or impact insulation class would be equal to footsteps or impact sound. If something gets dropped on the floor, you're dragging a piece of furniture across the floor. Those are impact sounds, including some vibrations and what have you. The other is STC or sound transmission class. That's defining airborne sound or noises that come through a wall, like voices in the other room, or windows that are single pane glass versus insulated doubles and stuff like that. What we're interested in here when it comes to a membrane or an underlayment, the delta IIC is what we're after. That would be the improvement in a floor searing assembly provided by a membrane. So this is a little example, like I'm saying, a graphic example of noise categories. The guy walking across the floor there, and he's got hard shoes on, that heel hits that floor, and it creates a vibration that transmits through to the space below. Whereas on the right there, the STC or airborne sound, stuff like TVs, people talking, music, et cetera, et cetera. When you look at the built environment, how does sound travel becomes a good question. If you look at that diagram, start at the top left, flanking noises come through cracks or openings over top a drop ceiling, openings in the roof. For example, you have an attic fan or some type of ventilation system that's open to the outside. A car or a truck could be driving by, and that noise, airborne noise, will travel through and creep into the room. Ductwork, HVAC noises, whether it be fans, sheet metal creaking and banging around, again, windows, unit ventilators, like for example, in a hotel room, there's that wall mounted thing that always squeaks during the night, keeps you awake. But when it's not running, you can hear noises through that because it's a flanking noise. Noises from outside will come through that open air space, and you can hear voices outside, or you can hear a car door or whatever. These are all things that are taken into consideration by an architect or an engineer when creating comfortable space. Typically, it's, again, a condominium, could be a hotel room, could be a lot of different things, but all of those things in that little picture there come into play. It's not just an underlayment for tile. Let's dial it up here. Impact insulation class measurement. It's a standard used to quantify the transmission of impact sound energy through a floor ceiling assembly. For example, like it says there, foot traffic, drop something on the floor, moving across the floor, a dog walking across the floor, something as simple as that with long toenails and stuff. You hear that clicking noise. That's an impact. That will travel through the concrete slab and or a wood structure. I like to, because I'm old enough, I can say this. In Mom's house, you're upstairs and you bang on the cast iron radiator with something and you can hear it in the basement, just as clear as day. That's an example of an impact insulation class noise. Okay, how do we measure this? Okay, it gets loud. This is a tapping machine that's used out in the field, and you can see there's that box on the left. Inside there is an electric motor and a crankshaft attached to that shaft with the 4-liter the 4 hammers. And as that thing rotates, it's banging on the floor, making all kinds of noise. We measure the amount of noise that thing is making in the same room. And then what we do is set up a listening device in the room below, and the difference in the two is going to tell us how much sound or vibration is being taken out of the system with a membrane or ceiling or whatever the flooring situation is. So that's how that works. If you ever have the opportunity to see one of these things in operation, you should check it out. Just beware, on a tile floor, that thing is really, really loud. Okay, so this is the most important test, I believe. It is the one that truly defines the value of a single component or a hard surface flooring system with a membrane. It's ASTM E2179, as it says. The way this works is you go into a lab and you measure the bare concrete slab first. In other words, there's no floor covering. It's in a sterile environment. You measure they put that tapping machine up there on top of the slab. They measure that noise, and then they listen below. And there's going to be a reduction just through the concrete slab itself. Then the underlayment system is installed on the concrete slab, and you can put on top of that ceramic tile, stone tile, you can put hardwood, you can put LVT, put whatever you want up there, and then you run the test again. The delta or change in the IIC rating is the performance gain between the first and second test. And typically what we're finding is with a hard surface floor, such as a tile, a porcelain tile, for example, that tile adds no value to the system because it's so thin and hard. And what we're seeing is the difference, average for a good quality membrane, 21, 22 decibel reduction. That's the value of the membrane. That's one of the most important things about this entire process, is understanding the value of the component. Okay. As I said, this measurement standard then is reported over a scale, if you will, of frequency ranges from 200 hertz, which is way down in the low bass end of it, all the way up to 4,000 hertz, which is a super high-end ping, if you will. And it averages that entire spectrum and comes up with a number. Some membranes perform better in the lower end of the scale, the 400 to 600 hertz range, which is that dull thud that you get from dropping something on the floor, moving furniture and footfall and what have you. Other membranes perform better in the mid and upper range, depend on our composition of the material, etc. But there's no specific rule or reporting on that individual product. The whole number is averaged over the entire spectrum. Just keep that in mind. If you have a number that's pretty good, but you want to still take out more of the low end, whether it be because somebody has a subwoofer sitting on the floor, because they have a lot of music things going on, footfalls, you need to add to it something on the ceiling piece below, typically a 5/8 chip ceiling or double 5/8. That's got a lot of density and mass to it. That helps to take out the lower end. Our Super Sand 125 membrane is 125 mils thick peel and stick. It's crack isolation as well. This material has been tested time and time again, and it contributes up to 22 decibels of IIC value to a floor ceiling assembly. So if you're dealing with a condominium association where you have post-tension concrete, a 6-inch slab typically is around a 30 decibel improvement by itself. Adding this membrane to it with tile or stone or hardwood, actually hardwood adds just a tiny bit, you will meet the building codes with just this membrane alone. It does not require a ceiling component below. We'll talk a little bit more about that in a minute. So a sound rated floor system, and we see this a lot in marketing now. So we got to get, I hope there's nobody here in marketing that's going to be offended. A floor system that utilizes a sound control underlayment and a sound rated ceiling assembly to achieve what you're trying to get to. We see this a lot in a high rise, not so much anymore, especially markets like Florida, for example, that's post-tension concrete. They do not put in a drop ceiling or a gyp ceiling. They will spray that popcorn stuff right up onto the concrete, or if they do put a ceiling, it's not sound rated. So what happens is the manufacturer of these membrane products is going to come out and they're going to say, well, use our membrane and you're going to get a 60 IIC. And what that means is they're using this test method, E492. Okay, same tapping machine, impact vibrations are created, different positions on the floor, etc. And they do this whole thing in a laboratory, but the point here with E492 is that it is for an entire floor ceiling assembly. That's what they're testing. 492 does not test the slab first. They're just doing one shot with the whole package. So we really don't know specifically or scientifically how much each component is contributing. That's one of the things to watch out for. What test method is it? Now we look at sound transmission class. This is a measurement used to quantify airborne sounds, as we talked about, voices, radio, TV, et cetera, et cetera. That test method is E90, and it's conducted in a similar manner, only instead of a tapping machine, there's a device that creates white noise, as we would call it, and we measure that noise in the room where it's being created, and then we'll bring the listening device downstairs, or in this case, or in some cases, to an adjacent room next door if you're testing a wall assembly, and they'll listen on the other side of that. And then the reduction in sound transmission, airborne sound transmission through the floor, through the walls, etc., will give us what that STC value is, okay? So they have STC for sound, and this E90 is a lab test. Again, when you do something out in the field, as you recall looking at that illustration we had, once you get on the field, there's so many variables, electrical outlets, AC, vents, windows. That's going to change the number. And there are protocols out there for field testing as well. There it is, okay? FIIC or FSTC, F denoting the field. And typically, they'll adjust those numbers by 5 decibels. So if your goal to meet the building code is an IIC of 50 or a 50 decibel reduction to meet the code, in the field, if you do that test out there, an as-built situation, and come up with a 45, you're still compliant. Again, that 5 decibel variation or standard deviation for field is because of the as-built conditions and the things that happen. It's not a sterile environment. So, again, room size, furnishings in the room. If you have, we've all been in a situation where you go into a room where it's all ceramic tile floor, stuff like that. It's a hard floor, there's no rugs, and there's a wooden or a metal and glass dining room table sitting there. Those things don't absorb any sound. You put down an area rug, you have different types of fabrics, window coverings and stuff like that. The noise inside the room begins to become more comfortable because it's not bouncing around off the walls. Those things will also improve STC values from one room to the next. Okay, and again, obviously, putting a throw rug down on a hard surface floor is going to help with your IIC value as well. All these things come into play. So the building code requirements for most jurisdictions is an IIC value of 50 and STC of 50. Some, and again, field, I think the next slide tells you a little bit more about this. The higher the value, the better sound attenuation and performance. Once you reach that 50 to 55 range on IIC values, depending on your floor covering and your membranes and what have you, to get to 60, or as we say here, incremental improvement is very, very difficult because now you have to incorporate a lot of different components that help at different frequency ranges. So again, be well aware of the marketing where someone comes up and says, well, yeah, use my product, you get a 60 or a 65. I've seen as high as 70. You have to look very carefully at that product data sheet so you can discern what is it that you're telling me. Because there's no single membrane out there that I've seen in 25 years that does any better than about a 23 or 24 decibel improvement for the membrane. People add all kinds of goodies to the floor ceiling assembly. They'll put insulation in the cavity, double gyp, hung ceiling, all kinds of things to get that big number and then say, use us, you get this. And it's just not true. It's just not true. Building codes, you can see here on the left-hand column, BOCA code is a little bit more generous. It's a 45, ICBO 45. IBC is an IIC of 50 with a field of 45. Okay, Florida, which is very difficult, typically, IIC 50 and a field of 45. And you look on the right-hand side there, HUD and FHA, their IIC is a 52. They're trying to up the deal a little bit and get some better quality in there. National Association of Home Builders, they've upped it to 55, almost to 60. Again, it's really difficult to get there on a 6-inch concrete post-tension slab with just a membrane. There has to be something else in that assembly to get to those numbers. And the Condo Association, I don't think anybody can get to an 80 with a hard surface floor unless there's ceilings and insulation and all kinds of things happening in there. But those, these are typical things we see out here. The one that I'm most concerned about is the International Building Code. That seems to be the general standard, other than some associations want to kick it up a notch, just like HUD did there. Picking on Florida just a little bit, their codes, Sound Transmission Code Section 1207, for airborne sound, they're very keen on penetrations and openings in construction, like pipes, electrical devices, cabinets, all those things we were talking about earlier. They all have to be sealed with an acoustical sealant or a joint sealant that will not harden up like some caulking materials do or some packing materials. This does not apply, however, to a dwelling unit entrance door, okay? But they should be tight fitting to the frame and sill. We would hope they would be anyway. But that's what the building officials look for in Florida. And there are some other jurisdictions that are starting to adopt a lot of this stuff. So it's, you know, we're in the flooring business. We want to go out there and put in an outstanding product. But if there's a complaint about noise, especially airborne noise, we want to be aware of what a lot of the other trades are responsible for as well. That's why I got this in here. Going back a little bit to the ASTM 2179 information, these are typical ranges for a concrete slab. You'll see a 6-inch, the second line there is 26 to 30 decibel improvement just because of the mass and density of that slab. It's a 4 decibel range because you can test that today. You know, I live in beautiful southern New Jersey, and today's a nice sunny day with low humidity. And then in a few days, when the remnants of Hurricane Laura comes barreling through here, it's going to be hot and humid. I'll measure that slab again, and the number will be different based on the relative humidity and moisture that that slab has absorbed. So that's taken into account. We like to say, at NAC, we like to look at that and say a 6-inch slab will average a 28. Okay, we try to be honest and be upfront, put it right in the middle. Hollow core slabs, obviously there's airspace in the slab. Those 6-inch and 8-inch hollow cores, they're not that good when it comes to acoustical values. Again, this is where it's critical to look at the materials you're using and get that delta IIC on the material coupled with the substrate that you're looking at here to ensure that we're going to get the best possible scenario. When we look at sound-rated ceiling assemblies, this little drawing here is just a kind of a generic hanger configuration. You cannot use J-channel or Z-strips or anything like that and connect it to the bottom of the slab or, in some cases, wood framing, and then screw your sheetrock right to it, because now you have a rigid connection. Any vibrations will go right through the screws, any metal strips and hanging devices that you have. This one you're looking at here, those are 2-component hangers. There's a rubber gasket in the middle that stops that vibration from going through. We're also showing a little bit of insulation in there. So something like that is going to add substantial value, depending on what type of wallboard you're using. If you're using a metal grid and drop-in panels, for example, the hangers that attach the grid to the framing above are critical. All those things add up. Sound-rated ceiling assemblies, they add value both STC and IIC. There's no standards, however, that make up a sound-rated ceiling assembly. This is where the acoustic engineer comes into play. Different components such as the hangers, the ceiling material itself, Type X, gypsum, a double 5/8 chip, all these things come into play. Multifamily, again, we're seeing a lot of modern construction where there is no sound-rated ceiling, which just adds to the challenge here. So beware of the numbers game. I've been saying it all afternoon here. Some people will market things in the 60s or the 70s. You can't get that with a concrete slab and a membrane if you don't have a ceiling assembly attached to that somehow. Again, the difference between the E492 test and the E2179 test. And again, products marketed based on superior performance over specific frequencies. Again, the composition of a material may be better at the low end of the frequency range versus the high end. Understanding that the standards, that last bullet point there, require results calculated over the entire range. It is not selective. So you got to take a real good look, ask the sales reps or the technical people about their products and where they perform best. When specifying or reading the specs, some materials out there are too resilient to bond tile or stone directly to. They're made more for the hardwood groups or LVT. They're a little softer. When you put in a hard surface floor like tile, you have to be keenly aware of point loads, rolling loads, and things like that. Our products are designed for ceramic tile and stone. They're reasonably stiff. They pass all of the Robinson floor tests and everything that's out there to ensure that your tile floor is going to be strong enough to support the loads. Bond testing, minimum is 50 pounds per square inch for the membrane to be bonded to the floor. Again, another tile side type of a test that's out there. Installation, follow the manufacturer's written instructions by all means, please. And also, when installing, methods are going to depend, vary depending on the material. Some are peel and stick. Some require an additional adhesive. Some require cement mortar as their adhesive. And when you do install these things, make sure it's done properly. Perimeter isolation is critical. Walls and partitions, you cannot have the hard surface flooring touching the wall. So if you have somebody out there spreading thin set mortar and they get it up against the wall, or when they're grouting the floor, they push it, they grout into the perimeter where there should be a soft joint. Now you have a rigid connection between the tile floor and the wall, and that it impacts your performance, up to 10% or so. Hardwood, that should not be touching the wall, the cabinet, any other fixture. You have to isolate that hard surface flooring on top of that membrane. Perimeter isolation, again, if you're going to use wood or tile base and you use a shoe molding or something like that, it cannot be touching that hard surface floor. Again, you make a connection and you reduce the value of that whole deal. And I've been on many, many jobs with tile where they use typical colonial base or something like that rather than ceramic base. We pop a piece of the base off the wall there, and that edge underneath is all filled up with grout. And these are the things, again, that connection, the connection between the tile floor and the wall has to be left open. An example of that is right here. There's a little drawing we made up. Use elastomeric sealant. On the side there, the backer rod and the sealant, that may not be necessary, but oftentimes we like to say, take a piece of the sound abatement membrane, cut it into little strips, and lay it up against the wall. And then when you're finished, just cut it off, trim off any excess. Those are critical components when it comes to dealing with how sound travels. Here's another little example. Okay, in renovation, we have wire membrane is important. For sound, obviously, we're talking about low profile. On a concrete floor, you can relocate a saw cut or a crack in the concrete. The sound membranes accommodate all that. There's all kinds of different things you can do. So to review this real quick, to ensure compliance, make sure you read all the data. Take a look carefully, ask a lot of questions. The ANSI 118.13 standard is for sound underlayment. It is in the ceramic tile and stone arena. Make sure you hit the building code requirements, depending on where you are. Some local jurisdictions may be higher. And make sure you're meeting your client requirements as well. Qualified labor, I think, is the most important piece here. If a contractor doesn't understand how these components work or how to install them, you could have the whole job put in and look gorgeous, but be dysfunctional because we've not paid attention to things such as perimeter isolation. With hardwood, I can't tell you how many times I've seen beautiful 3/4 inch hardwood gorgeous floors over a sound attenuation membrane, and the complaints come, and we go out there. He laid down the membrane and he nailed the floor down with 1,000 nails. But you just created a rigid connection between the floor and the frame. If you're going to use a sound attenuation membrane, it has to be a floating floor or something that's installed with an adhesive. You cannot put nails through it. That's pretty obvious. We all know that. So our membranes, we have two. SAM3 is a 90 mil. It meets all the standards with or without a sound rated ceiling. And earlier I had a picture of our sound abatement membrane 125, which provides you a 22 decibel improvement, can be used directly over a concrete slab with no ceiling below and meet all of the building code requirements pretty much anywhere in the USA. So those are the things that I have. This is my contact information. Our website address is right there. I hope I didn't bore you to death. It's kind of dry technical information, but there's a lot of very critical components to this. I just don't want to see anybody get in trouble, have to tear something out and do it again, or get into litigation over something like that. That's just ridiculous. That's pretty much what I have. I'm not sure if Dave Hanna, who's our Director of Marketing and Technical Services at NAC, he was kind of keeping an eye on some of the questions. Does anybody have any questions? Hit that Q&A button up there and type away.
Yes, thank you so much, David. So as David said, if there are any questions, please submit them in the Q&A feature on the screen.
I must have answered everybody's questions.
Yeah.
That's good.
Well,
on the screen right now is for condo associations more than anything for a tile floor. This is just an illustration of how our system works for waterproofing, anti-fracture, and sound attenuation, all in one shot there too. So we have a lot of answers for the built environment when it comes to flooring, so feel free to reach out to us.
Yes, thank you. So if there aren't any questions for David, then thanks, David, for presenting the webinar today. We really appreciate it. Oh, we just had a question come in. How important is the type of acoustic sealant between the tile and the wall?
That's from John. I believe that the type is critically important. It needs to be something that is been tested as an acoustic sealant. Typically, they're silicone materials that remain soft. Sometimes we see latex caulking being used in there and some other stuff that tend to harden up over time. You want to stay away from those types of materials. Typically, you can go to your suppliers that handle that type of material and ask specifically for acoustic sealants, John, and they'll hook you right up.
Great, thanks. We had another question come in. Are these approved for under carpet tiles in a hotel in a double glue down install? And if so, what types of adhesives?
Yes, you can use our 90 mil and our 125 mil sound membranes under typical carpet tiles, as long as the adhesives to bond the carpet tiles are not solvent-borne materials. Typically, any acrylic adhesive, which I believe encompasses most of the materials that you guys are using out there now for carpet, you're totally good to go. I would guess, Brad, that on that question, some of the carpet tiles are pretty thin and pretty stiff. They may not be adding enough IIC value, or there's still questions and complaints when they're bonded directly to a concrete slab. I would imagine that's what you're referring to, Brad, because I've seen that once or twice. And as they, in large, heavy traffic areas like convention centers, for example, they tend to compress over time. Still look great, they clean well, they service well, but they're they get pretty rigid over time. So yeah, you can use our membrane underneath that as long as it's an acrylic adhesive. No problem. Thank you, Brad.
Okay, well, if there aren't any more questions, then on behalf of the FCICA, thank you, David, for the presentation today.
Well, thank you very much for having us. Again, we're here to help, even if it's just questions that we can help you find answers, do research with you, whatever we can do to help you guys be more successful. Hopefully that leads to a little business. But first and foremost, as I said in the open, I hope that everybody here and all your families and friends remain safe with all the things we're dealing with, especially this year for some reason. It's crazy. Again, thank you very much and stay safe, everybody.
Great, thank you. And Sims, you may now navigate to the Submit Credit tab to receive credit for attending this presentation. Please note that you must be signed in to the education platform for this feature to work. If you have any issues, please let us know. Thank you so much for joining us and have a great rest of your day.